Hello, my name is Jordan Santos. I'm a medical student at OSU Center for Health Sciences, and my project is the synthetic cannabinoid WIN55 leads to changes of pro and mature BDNF ratio levels in the PAG and blood concentrations in the adolescent rat. Marijuana, which is the most prevalently abused illicit drug among American adolescents, is a psychoactive drug that activates cannabinoid 1 or CB1 receptors in the brain. When administered to adolescent rats and mice, cannabinoids lead to long-lasting deficits. This vulnerability might involve some brain areas that are densely packed with CB1 receptors and are linked to decision-making and reward processing, such as the nucleus accumbens, ventral tegmental area, and periaqueductal gray area. Endocannabinoids and neurotrophins, particularly brain-derived neurotrophic factor, or BDNF, are potent neuromodulators that play critical roles in decision-making, reward processing, and motivation. BDNF within the mesocortical limbic dopamine system is a positive modulator of psychostimulant and opiate reward. Recent evidence suggests that BDNF released from the projection neurons in the PAG might participate in pain modulation in adult rats. While evidence suggests that BDNF might participate in dopamine and endocannabinoid-mediated drug reward responses, the role of BDNF during development and in the presence of synthetic cannabinoids is still unknown. BDNF has well-established pro-survival effects, whereas its precursor protein, proBDNF, induces apoptosis. Thus, it has been suggested that the proBDNF mature BDNF ratio could indicate neuronal health. However, the roles of pro and mature BDNF after synthetic cannabinoid exposure during the critical adolescent period is not clearly understood. Therefore, our study aimed to evaluate the effect of adolescent exposure to the synthetic cannabinoid WIN55 on the pro-BDNF mature BDNF levels in the PAG and blood concentration in adolescent rats. We administered 5 daily intraperitoneal injections of either vehicle or the cannabinoid agonist WIN55 every other day. The rats were sacrificed 90 minutes after the last WIN injection on postnatal day 38. We then collected brain and blood samples from the animals to analyze. Brain tissue and serum were used in an ELISA immunoassay to determine the concentrations for pro and mature BDNF. We used a one-way ANOVA to analyze the ELISA results and found significant increases in both pro and mature BDNF levels within the PAG of rats treated with WIN55 when compared to saline-treated rats. The analysis also showed a significant increase in pro BDNF levels in the serum of rats treated with WIN55 when compared to drug-naive rats. However, the one-way ANOVA failed to show significant differences in mature BDNF levels in the serum of WIN-treated rats in comparison to saline-treated rats, although the data suggests an increased trend line for mature BDNF levels in the periphery. We found that chronic exposure of the synthetic CB1 agonist modified the pro-BDNF ratio drastically, increasing pro-BDNF levels by 33% and mature BDNF levels by 47% in the dorsal PAG. Pro-BDNF blood concentrations were significantly increased by 47% when compared to drug-naive rats. Our study revealed that synthetic CB1 receptors during adolescence significantly increased pro-BDNF levels in brain tissue and blood, demonstrating that the PAG and pro-BDNF mature BDNF ratio are involved in endocannabinoid-mediated neurotransmission. Thank you.